What's up? It's still the great teacher Alcantara here, and we're going to talk about systems of linear equations. This time around, we're going to focus on the substitution method. Let's just jump right into it. Now we're going to go with substitution method, and our targets are as follow. We're going to solve systems of linear equations in two variables by substitution method, and we're going to work on word problems this time around also at the same time, so that we could maximize our time with these concepts, so that we're going to hit two targets at once. So we're going to start with the word problem immediately, since we have identified what kinds of systems there are already from the previous lesson. So let's say that we have this first word problem. Itadori is forced to solve systems of linear equations by substitution method as part of his training. Goido Sensei left him with the following equations, the first one being x minus y equal to 5, and the second one being x plus y equal to 19. What are the things that he need to consider before he could do the substitution method? And here's an important note. For substitution method to work, we have to check if there's an equation in which, a variable is already isolated. If none, we may isolate any variable in any of the equations before we proceed with substitution. Now, that seemed a bit far-fetched, so let's try to clarify that thing right here. So, for example, you have here the two equations. On the guide on the left, you're being told to choose one equation that will be substituted to the other. Now, what I will choose here is the first one. I will use this one to be substituted to the other. So what I will do with this first equation, x minus y equal to 5, is to follow what the second step is telling me to do, and to isolate one of the variables of the chosen equation before substituting. I want you to understand here that substitution method can work in 4 different ways. Okay? You may choose what equation first to isolate with, and then choose what variable to isolate with. Now, I'm going to choose the first equation, x minus y equal to 5, and I wish to isolate the x variable. Since I want to isolate the x variable, I want to eliminate the term next to it, transfer it to the other side. So you have there minus y, right? So to isolate the x variable, I will add y to both sides. Again, the goal here is to isolate the x variable. Doing so, you will have x is equal to y plus 5. Now, we have isolated the x variable from the first equation. So to do substitution method, the resulting equation that you get from the one that you have isolated, you're going to substitute that to your other equation. Note, do not substitute the result to the same equation. Substitute it to the other one. So that's where we're going to use our second equation. Okay? So for the second equation, we have x plus y equal to 19. Take note that there's a variable x here, and we have x equal to y plus 5. So by substitution method, we're gonna change our x here as y plus 5. Why? Because x is equal to y plus 5. Therefore, again, this will look like y plus 5 plus y equal to 19. I repeat what happened here. We substituted the x being y plus 5 from our first equation to our second equation. Doing so, as you can notice, we have y plus 5 plus y equal to 19, where we have the like terms y and y. That's equal to 2y plus 5 equal to 19. And again, the goal here now is to isolate the remaining variable. Here, in this case, the y variable is the remaining variable. So we subtract 5 to both sides. You will get 2y equal to 14. To isolate the y variable completely, divide the two things by 2. You'll get y is equal to 7. And since now you have y is equal to 7, you have received a value. This means that you could also get the value of x. And the beauty of this is that you can substitute this now to any of the two equations. So let's say that I will substitute y equal to 7. So let y equal to 7, and I will use the first equation again. So let's say we have x minus y equal to 5. I'll make my y 7, so it will be x minus 7 equal to 5. To get the value of x, add y to both sides to isolate it completely, and you will have your Why did I write y? I'm so sorry. It should be 7. Okay, forgive me for that. 7. So you will get x is equal to 12. So now you have the value for x, you have the value for y. So this means that you can write an ordered pair. The solution can be found at 12, 7. Because your x is 12, your y is 7. Meaning, since we have this kind of result, we have an ordered pair. This means that our system is consistent and independent. Again, the reason behind this is because there is an ordered pair as a solution that we can form. This implies that the lines are intersecting. So this is what you can take note of it. When you graph it, it's going to be intersecting lines. I clicked Siri for some reason.
Here's what I found.
Sorry for that. Wait, Siri. Okay, Siri's down. Now, again, we formed an ordered pair, 12, 7. So it's consistent and independent, and there's intersecting lines. Again, for substitution method to work, we choose an equation that we wish to isolate a variable with, and then we will substitute that to the other equation. Let's have one more example. Let's have 4x plus 7y equal to 19, and now we have y is equal to x plus 9. Now, this is what I've been talking about. Here, you can notice that there are two equations, 4x plus 7y equal to 19, and take note of your equation number 2. Y is equal to x plus 9. Y is already isolated, so you will substitute that to the first equation. So, if you have 4x plus 7y equal to 19, since again, the y is already isolated, change your y to that. But here's something important that I want you to understand. Since your y there is equal to a binomial and there is a numerical coefficient, you have to be careful. So it will be 4x plus 7. And since it's a binomial, you have to multiply the entire thing to the number. It's not just 7x plus 9. That's going to be wrong. Since y is an entire binomial, multiply it to the numerical coefficient 7. So to continue, you will have 4x plus 7 times x is 7x, 7 times 9 is 63, equal to 19. Okay? And then to follow, you will have 4x plus 7x, that's 11x, plus 63, equal to 19. So subtract 63 to both sides to isolate the x variable, the remaining variable that we have here. So we will have 11x. What's the answer here? 44. Negative 44. So to continue, divide the entire thing by 11 to isolate the x variable. So you will have x being equal to negative 4. So now you have your x variable. Again, substitute it to any of the equations. So I'll substitute it to the second one. So let x equal to negative 4. I'll use the second equation. So that's the easiest. Again, you can substitute it to any of the equations, but be smart with it. Use the easiest one for you. So I'll substitute that one. You'll have negative 4 plus 9. So your y is equal to 5. So now I have a value for my x and y. Therefore, it can be in the ordered pair. It is in the ordered pair, negative 4, 5, where they intersected. Again, this is intersecting because we have managed to form an ordered pair. So this will make the system consistent and independent. Don't worry, it will be much clearer later. Same with the summary that was presented with the previous video. So it is intersecting lines because there is an ordered pair form based on the solution. Again, you may maximize the use of any equations here. If you want to make it hard for yourself, you may isolate different variables from different equations. But again, if it's already there in the easiest way possible, go do it. Okay, the guide is there to help you out. And again, if there's a variable already isolated, if I were you, that's the one that I'm going to use. Okay, so the important detail here I would like to discuss again, since this is a binomial, you will multiply it to the entire numerical coefficient. The numerical coefficient should be multiplied to the entire binomial, not just x, okay? So let's continue with some more examples. let's have this one. Now in here, just like the first example, the variable is not yet isolated. For me, the easiest one to manipulate is the first one. So let's work on that. We have x plus y equal to 9. I will isolate the x variable. So I'll subtract y to both sides. I will get x is equal to negative y plus 9. So now that I have this from my first equation, I will substitute it to the second equation. So let's let x equal to negative y plus 9. Doing so, you have 2x plus 2y equal to 18. Change the x to the value that we got, so we'll have 2 times negative y plus 9 plus 2y equal to 18. Doing so, you will have negative 2y. 2 times negative y is negative 2y. 2 times 9 is positive 18 plus 2y equal to 18. Now, if you have negative 2y plus 2y, the answer there will be 0. Negative 2y plus 2y, that is 0. So you will be left with 18 is equal to 18. And now you're wondering, there wasn't any variable isolated. What does that mean? Look at your resulting equation. You have 18 is equal to 18. This is a true statement. It's true, right? 18 is equal to 18. But we weren't able to identify x or y here. What does that imply with this system? This means that your system is the same. Your system here is consistent, but they are dependent. Because if you graph this specific system, it will be coinciding. Not believing me? Let us maximize the things that we discussed from the previous concept. So I have the first equation being x plus y equal to 9. My second equation is 2x plus 2y equal to 18. The second equation can be simplified because they have a GCF, which is 2. And believe me not, it will become x plus y equal to 9. So as you can notice, the equations are technically the same. That makes our system consistent and dependent with one another, and it's coinciding. So when you're doing substitution method and elimination method in the near future, you can say that a system is coinciding, consistent, and dependent if you have a true statement as a result. Okay, it's not an ordered pair, but it's a true statement. Okay, it gets a bit confusing here, I know, but it will be much clearer once we see an example where we get a false statement. Now let's go with another one. You have here x minus y equal to 9, 2x minus 2y equal to 22. I prefer to use the first equation to isolate with, so I'll use that one. X minus y equal to 9. I'll add y to both sides to isolate the x variable. I will get x is equal to y plus 9. So now I will substitute that to the second equation, so let x equal to y plus 9. Doing so, you will have 2x minus 2y is equal to 22. 2 times your value for x, which is y plus 9, minus 2y equal to 22. 2 times y is 2y. 2 times 9 is 18, minus 2y equal to 22. Now you have here 2y and negative 2y. That can be simplified as 0. You'll be left with 18 is equal to 22. Now, as you can notice, 18 is not equal to 22. This results to a false statement. Now that it is false, this could mean one thing. It is inconsistent. So if something is inconsistent, that means it's false in terms of the result. Because when you graph this is actually a set of parallel lines. That's why it's inconsistent. Don't believe me? Let's try to do what was told of us from the previous lesson. So you put your equations to slope intercept if you want to. You can have here by adding subtracting x to both sides first, you will get negative y is equal to negative x plus 9. Divide the entire thing by negative 1. you will have y is equal to x minus 9. Doing the second one, you will have 2x minus 2y equal to 22. Subtract 2x to both sides to isolate the y variable. Negative 2y equal to negative 2x plus 22. Divide the entire thing by negative 2 to isolate the y variable. You will get y is equal to x minus 11. As you can notice, the y's are the same. Y's are the same. The x's are the same, but the y-intercepts are different. That's why they are parallel. The slopes here are both 1, but the y-intercept for the first one is negative 9. The y-intercept for the second one is negative 11. So that results to a false statement. Again, you don't have to show the second part of this one. It's just a proof that, again, we result to a false statement, meaning that we have we have two lines that are parallel and the system is inconsistent. I started a lot in there. I'm so sorry. Let's continue with some more examples. I think we have a word problem. Not yet. Oh, not yet pala. Have one more. Two more before the word problems. So we have y minus 2x equal to 0. We have negative 6x plus 3y is equal to 16. The easiest here is the first one. Okay? So let us manipulate that. Y minus 2x is equal to 0. Add 2x to both sides to isolate the y variable. Just a disclaimer, the reason why I find it the easiest because I don't like negative numbers. I don't want dividing things by negative 1 or negative 2. If I see, so basically the technique here is that if you see a positive variable isolated or in that side on the left already, you can maximize that. No need to do 10,000 steps to isolate a variable depending on the given, okay? Depending on the given. If it's easy like this. So to continue, you will have y is equal to 2x. That's it. 0 plus 2x is 2x. So let y equal to 2x. Doing so, you will have negative 6x plus 3y equal to 16. Substitute the 2x there. You have negative 6x plus 3 times 2x equal to 16. So you will result with negative 6x plus 6x equal to 16. Okay? Negative 6x plus 6x, that is 0, equal to 16. So this resulted to a false statement, just like the previous one. Meaning, we have parallel lines, no solution, of course. There's no solution for parallel lines, meaning we have a inconsistent system. An inconsistent system. Okay, so that's it. As easy as that. It's inconsistent. Let's have another one. Negative 2x plus 3y is equal to 14, and we have x plus 2y is equal to 7. I will use the second equation this time around because I find the x there. It's the easiest one to manipulate. So, doing so with the second equation, x plus 2y equal to 7, I will isolate the x variable by subtracting 2y to both sides. I will get x is equal to negative 2y plus 7. Doing so, let x be equal to negative 2y plus 7. Substitute that right there for the first equation. You will have negative 2x plus 3y equal to 14. This will be negative 2 times negative 2y plus 7 plus 3y equal to 14. Doing so, you will now have 4y positive. Negative 2 times 7, that will give you negative 14 plus 3y is equal to 14. So 4y plus 3y, those are like terms that's equal to 7y minus 14 equal to 14. Add 14 to both sides. Let's continue it on this side right here. I'm so sorry. So we will have 7y equal to 28. Divide the entire thing by 7. And you will get y is equal to 4. Finally, with an ordered pair, right? So substitute that to any of the equations. I'll choose the second one. So let y equal to 4. And I will choose the second equation, x plus 2y equal to 7, because I find that as the easiest equation to use. So I'll have x plus 2 times 4 equal to 7, x plus 8 equal to 7. Subtract 8 to both sides to isolate the x variable, and you will have x is equal to negative 1. Therefore, you will have an ordered pair at negative 1, 4, meaning this is consistent, independent, because you have here intersecting lines. So that's how it works. You have intersecting lines here. There is one solution. Again, there is one solution if you are able to form an ordered pair. So that's how it works. Okay, so now we're gonna work on word problems so that we'll get used to it and it will no longer be a problem. See what I did there? So let's start with our first word problem. We have here, Miwa was tasked to open up a safe whose password is made up of two numbers for her to figure out. The clues are as follow. The difference between the two numbers is 28. The larger number is 4 more than twice the smaller one. So what should be the password? Now, please take note when dealing with word problems, it is important for us to label our variables properly and then write the corresponding linear equations in two variables that satisfies the given problem. So in here, we're talking about two numbers, right? Two numbers. So what I will do is I have to emphasize which one would be x and which one should be y. Since there is a larger and a smaller number, let's say that x is the larger number. Forgive my lovely handwriting. And then let's make y as our smaller number. Thus, this alone will help us in identifying the equations. It says here that the difference between the two numbers is 28. So we can say that our first equation is x minus y equal to 28 because the difference, meaning subtraction. Now it says here that the larger number is 4 more than twice the smaller. So what we can do here, since it says the larger number is x, and is actually implying a certain symbol, which is the equal sign. 4 more than twice the smaller. So we start with twice the smaller first. So that will be 3y. 4 more than, that means plus 4. So it's x is equal to 3y plus 4. Okay? Because more than twice the smaller. So twice the smaller is 3y. Then 4 more than, so plus 4. So our x is equal to 3y plus 4. And thus, if you can see here, the most appropriate method to use here is the substitution method, the easiest one. So let's do that one right here. Doing so, let's substitute the second one to the first one. So we will let x equal to 3y plus 4. Substitute that to our first equation, which is x minus y equal to 28. Make your x become 3y plus 4. So 3y plus 4 minus y is equal to 28. So you have here 3y and negative y as like terms. Simplify that, you will get 2y, then plus 4 is equal to 28. Subtract 4 to both sides. To isolate the y variable, you will get 2y is equal to 24. Now that's out of the way, divide the entire thing by 2. You will get y is equal to 12. So that is your first one. So now we will let y equal to 12. So in this case, we can substitute that to any of the equations. I'll choose the second one. That's the easiest. X is equal to 3y plus 4. So x is equal to 3 times 12 plus 4. 3 times 12, that will be equal to 36 plus 4. And then that will give you x is equal to 40. So the password will probably be 40 and 12 because 40 minus 12 is 28. 40 is equal to 36 plus 4. So that's it. So your answer here is an ordered pair at 40, 12. So that's the password, 40 and 12. That sequence. This is intersecting lines if you graph it. If you need to graph it, it's intersecting. What kind of system is this? Consistent and independent. So probably one of the concerns that you may have here is writing those linear equations first, but you don't have to worry. Again, the thing there, the skill there that you have to practice is, what do those words mean? How do we translate it into symbols? Okay, that's what we're practicing here. That's why we have a word problem to discuss with. And our last example, now that we're done with Miwa, let's go with our friend Maki. Maki. So Maki is training her accuracy while also helping out with the woodwork around Jujutsu High. She wants to cut each 16-foot piece of wood into two pieces using her Naginata curse tool. So the longer piece is to be 1 foot longer than twice the shorter piece. Find the length of the piece. So we know here again, just like earlier, we have two things that we have to take note of. So we're speaking of a wood being divided into two pieces. We have a longer piece and we have a shorter piece. So let's make X as our longer piece and our Y as our shorter piece. So that's how it works. In this case, if we look at that, 16-foot piece is the length of the wood in total before it's divided or cut into two pieces. So we can say that the longer piece plus the shorter piece is the entire thing being 16. So that's how it works. But the next one, the longer piece is, so similar to what we did earlier, X is equal to 1 foot longer twice the shorter. So twice the shorter is 2y. 1 foot longer than, so plus 1. So X is equal to 2y plus 1. So that's how it works. Okay? So it's just like the previous example. Doing so, as we continue, we can now start with the substitution method. So we will substitute the second equation to the first one because that's how we do. We don't have to make things complicated. So let X equal to 2y plus 1. And your equation there is X plus Y equal to 16. Change your X to 2y plus 1 plus Y equal to 16. 2y and y are both like terms, so you will have 3y plus 1 equal to 16. To isolate the y variable, subtract 1 to both sides. You will get 3y is equal to 15. Divide the entire thing by 3. You will get y is equal to 5. Now that you have y is equal to 5, you may substitute that to any of the equations. So let y equal to 5. I will choose the second equation because that's the easiest for me. So x is equal to 2y plus 1. So x is equal to 2 times 5 plus 1. 2 times 5 is equal to 10 plus 1. So x is equal to 11. Meaning, we have our ordered pair or the measurement for the wood. We have this as the longer and this is the shorter piece. If you write it an ordered pair, 11, 5, this means that this is intersecting when you graph it. And this makes the system consistent and independent. But since this is a word problem, you have to emphasize your final answer. So you have to take note of the following. That the longer piece is 11. And what's the measurement mentioned there? 11 centimeters, if I'm not mistaken. And then 5 centimeters for the shorter one. A foot, I'm so sorry. So take note of it properly. So the shorter is 5 foot, 11 foot. Just write it in complete sentence, okay? I have no time for it. Anyway, so that ends our discussion of the substitution method. And that ends the video about solving for systems of linear equations in two variables. Always remember to take note of the examples, practice them on your own so that you'll get used to it and master the concepts. And always remember what's up, and that is respect. And in case you don't see me, good morning, good afternoon, good evening, and good night. Bye bye bye.